this is Britt Caswell with another example video. In today's video, I'm covering example 1 from lesson 9-1 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to recognize solutions of quadratic equations. So remember, a quadratic equation is an equation that has degree 2. Alright, so it's something with an x squared chilling in there. Alright? And usually when we set the quadratic equation equal to 0, we're trying to figure out some kind of solution there. Alright? So usually we'll be dealing with what's called standard form of a quadratic equation, which looks like this. Ax squared plus bx plus c equals 0. Alright? If it's not in that form, 9 out of 10 times you need to get it in that form before you could do anything with it. Okay? And so to start out with, we're wondering, why are the x-intercepts of the graph of a quadratic function? So when we say graph of a quadratic function, remember we're talking about a parabola. So why are the x-intercepts of the parabola important to the solution of a related equation? Alright, so the real and true answer to this is that the x-intercepts of a parabola correspond to the solutions of the related equation. Alright, so if I have an equation and I know how to solve the equation, the answers that I get are where the parabola for that crosses the x-axis. Okay? So let's do an extension real quick. I want to show you guys how to solve this using square roots before you see where we're getting the -4 and 4 from. Okay? So if I want to solve this, the first thing I need to do is I need to get the square alone. Now mind you, this only works when you have just a quadratic term and there's no linear term. See how there's no x in here? There's just an x squared. So if you don't have a linear term, then you could just solve directly for the x squared without having to do extra work. So here I have x squared equals 16. And so then I'm going to take the square root of each side. Now remember, if ever you take a square root to undo a square, you have to put the plus or minus. Alright? So that little plus and minus symbol that's on there is saying that it could be a positive or a negative, whatever this is. So the square root of 16 is 4. So this means that there's two solutions. X equals 4 and x equals -4. And so you could actually see that here on the graph. Right here, here's our -4, here's our +4, and that's where this parabola is crossing on the x-axis. Now the other thing is there's a lot of different words that we use to describe a solution. So I want to make sure that we're comfortable and aware of some of those words. So we know solution. There's also x-intercept, zeros, or roots is another word for it, okay? So they have a lot of different phrasing for this. So just be aware that if they ask for any of these 4 things, they're all asking for the same thing, okay? So now we're going to do the try it. Alright, this one wants us to find the solution, but it wants us to do it based off the graph. So I'm going to pop out the graph. So check this out. We know this expression. If I take 14 and divide it by 2, it's 7. And 7 squared is 49. So this is actually a perfect square trinomial that factors to look like x minus 7 squared equals 0. Look at that 7. That's where that 7's coming from. So like I could take the square root of each side and get x minus 7. Oops, I don't need parentheses on that. X minus 7 equals 0. And then I could add 7 over. And so that's where you could see that one intersection point. Now notice on this that there's exactly one solution, because the parabola comes down and just kisses that x-axis and then turns away. And so the reason why that's happening is because this is a perfect square trinomial. Because we were able to collapse it into a single expression raised to the second power. Okay? So now on this one, it's worth noting, this expression is not factorable, right? There's nothing that multiplies to make 7 that adds to make 3. And so when you have stuff that's not factorable, it could mean two things. It could mean that there's no solution. Like you see here, this parabola never crosses the x-axis. Or it could mean that you have solutions that are at like really weird spaces, like the irrational numbers instead of whole numbers. And so that's what's happening here. So this one is no, I'm not going to say no solution. I'm going to say no real solution. As you guys grow up and get into Algebra 2, you guys will figure out that we have imaginary solutions that result from these parabolas that don't cross. Okay, so I'm saying no real solution because there aren't any real numbers that it's crossing on. So let's check out A and B here. Now for A, I could actually solve for this directly. If I wanted to, I could recognize that's a difference of squares, right? And I could call it x plus 6 and x minus 6. And so a trick that you're going to see in a little while for this is actually you could set each of these factors equal to 0 and use that to solve. So you're going to see that x equals negative 6 or x equals positive 6. Although this is in that same format of the extension that I just did. To get the plus or minus 6, you could do the same thing there. So two ways to solve, but here it is on the graph. You could see here's our negative 6 and there's our positive 6 for our solution. And then for part B is another one of those perfect square trinomials, right? This is the same thing as x plus 3 squared. So if I take the square root of each side, I get x plus 3 equals 0, which means that x equals negative 3. And so this is going to have one solution that touches the x-intercept at negative 3. And it's also worth noting that it's coming from the top and then touching it and then turning it away because our a value is a positive 1. So if you look at it, you can see there it is swooping in, kisses the x-axis at negative 3, and then it swoops away. So there we have it, guys. That is how to recognize solutions of a quadratic equation. Until next time.